Something is hiding at the edge of the universe, and the more we look, the more of them we find. Tiny red dots, scattered across the earliest images James Webb has ever captured. They appear 600 million years after the Big Bang in almost every single frame, and then, about a billion years later, they just disappear, like they were never there. We have no idea what they are. We have mapped the cosmic microwave background. We have watched black holes merge. We have photographed the shadow of a singularity 4 million times the mass of our sun. And yet these tiny red specks, hiding in plain sight across thousands of Webb images, have broken every model we've thrown at them. They're incredibly dense, dazzlingly bright, and far more massive than we'd expect. They produce a light signature that nothing in our current understanding of the universe can fully explain. Stars don't behave like this. Galaxies don't either. Black holes come close, but not close enough. So what are they? Well, some of the world's top astrophysicists believe we may be looking at an entirely new class of cosmic object, something that is part star, part black hole. If they are right, these little red dots are not just a mystery. They are a missing chapter in the story of how the universe itself was built. Welcome to Cosmic Chronicles. Since the James Webb Space Telescope launched on the 25th of December, 2021, it has completed over 32,000 hours of observation and sent back more than 600 terabytes of data. Everywhere Webb looked, it keeps finding the same thing: tiny, bright, mysterious red dots scattered across the oldest corners of the universe. They are in almost every single image, and nobody, not one astronomer on the planet, can fully explain what they are. They showed up 600 million years after the Big Bang, fill the early universe for about a billion years, and then just vanish. Gone. Like they were never there. Scientists have thrown everything at them: starburst galaxies, black holes, exotic new physics, and every single theory has run into a wall. But now, a new idea is gaining traction, and if it's right, we may have just discovered a completely new type of cosmic object. One that sits somewhere between a star and a black hole. Something that was predicted 2 decades ago and that nobody thought we'd ever actually find. Today, we're going to break down exactly what these little red dots are, why they're so strange, and why figuring them out could rewrite everything we thought we knew about how the universe grew up. Before we continue, we have noticed that 91% of you that watch this channel frequently do not subscribe. If you've ever enjoyed my video, please do me a favor and hit the subscribe button. It helps this channel more than you know, and the bigger the channel gets, the more valuable content you enjoy. When astronomers first started going through James Webb's images in 2022, they expected to find young galaxies, early stars, the usual cast of characters from the universe's first chapter. What they didn't expect was this: tiny red pinpricks of light appearing in practically every single frame. At first, people thought it was a calibration issue, an artifact of the telescope itself, but the dots kept showing up. Survey after survey, every deep field image, always there. The scientific community gave them a name: Little Red Dots, or LRDs, and the race to explain them began. They are no more than 500 light-years across, which, for context, is about 200 times smaller than the Milky Way. Despite their tiny size, they are dazzlingly bright. And they are red, really red. Part of the redness comes from something called redshift. The universe is expanding, and as light travels across billions of years of space, it gets stretched. Stretched light shifts towards the red end of the spectrum, so old objects always look redder to us. But when astronomers broke the little red dots' light apart into a detailed spectrum, they found that redshift alone couldn't explain how red these things were. There was something else going on. Buried inside each spectrum was a sharp feature called a Balmer break. This is a very specific dip in the light at 364.6 nanometers, the exact wavelength at which hydrogen absorbs light. Seeing a Balmer break in an object usually means one thing: it's packed full of hydrogen. And in a galaxy, that normally means young, hot stars. Lots of them. At first, astronomers thought these little red dots were starburst galaxies, compact regions of space exploding with new star formation. It made sense. Young stars are rich in hydrogen, which explains the Balmer break. A dense stellar population explains the brightness, and starburst galaxies tend to be full of dust, which would explain the redness. But there was a problem. That theory didn't add up. To explain the redness using dust, you would need an enormous amount of it. But dust in galaxies comes from stars, and there is a well-established relationship between how many stars a galaxy has and how much dust those stars produce. When researchers ran the numbers, they found the LRDs could only account for about 1% of the dust needed. 1%. That's not a small discrepancy. That's 2 orders of magnitude off. Then there was the density problem. To pack enough stars into an object that small to produce that much brightness, you would need them crammed so close together, just a few astronomical units apart, that they would be constantly colliding and merging. The gravitational dynamics would be completely unstable. The starburst theory was in trouble. So astronomers moved on to another theory: active black holes. At the centers of most galaxies sits a supermassive black hole, surrounded by a swirling disk of gas. When that black hole is actively feeding, it generates an extraordinary amount of light, some of the brightest objects in the universe. A black hole viewed edge-on, with a ring of dust blocking shorter wavelengths, could appear very red. The broad emission lines in the LRD spectra, a signature of gas spinning at thousands of kilometers per second around a massive central object, also pointed squarely at black holes. This theory seemed far more convincing, until astronomers noticed something critical was missing: X-rays. Active black holes always produce X-rays from their accretion disks. Always. But the little red dots had none. 0 X-ray signal. That should have been impossible if a hungry black hole was behind the glow. The mystery remained. But what exactly were these little red dots? In 2024, astrophysicist Anna de Graaf and her team launched the RUBIES survey, Red Unknowns, Bright Infrared Extragalactic Survey, spending nearly 60 hours of James Webb time hunting the rarest, reddest, most extreme objects in the sky. They confirmed dozens of LRDs and studied them in unprecedented detail. What they found made the mystery deeper. The LRDs were more diverse than anyone expected. Some seemed to be dusty star-forming galaxies. Others looked like they had stopped forming stars unusually early. Some showed clear signs of active black holes. It seemed both sides of the debate had a point, but within the sample, there was a subset that fit none of those categories. Objects with V-shaped spectra, broad emission lines, point source brightness, all the strange signatures that had resisted explanation from day one. And then they found one particular LRD, 11.9 billion light-years away, with a spectrum so extreme the team stopped and stared. They called it the cliff. Its Balmer break, that hydrogen signature, was almost vertical, twice as strong as anything ever observed in the ancient universe. To produce a break that sharp, you would need an enormous amount of very pure, homogeneous hydrogen gas wrapped around the light source, like a thick, dense stellar atmosphere. But the broad emission lines simultaneously pointed to a massive, rapidly feeding black hole. It was showing properties of both a star and a black hole at once. De Graaf's team concluded they were looking at something new. They called it a black hole star. A black hole star is exactly what it sounds like, and also nothing like what you'd imagine. Picture a supermassive black hole at the center, actively feeding, generating enormous amounts of energy. But instead of the surrounding gas dispersing, it stays bound. It wraps around the black hole in a vast, dense sphere of hydrogen gas. From the outside, it looks like a single, colossal star. But it's not powered by nuclear fusion. It's powered entirely by the black hole at its heart consuming gas. This model suddenly explains almost everything. The missing X-rays? They're not missing, they're trapped. The hydrogen envelope surrounding the black hole is so dense that X-rays can't punch through it. They get absorbed and re-emitted as the red optical light we see instead. The sharp Balmer break? That's the hydrogen atmosphere, thick and relatively uniform, absorbing light at exactly the right wavelength. The V-shaped spectra? A combination of the red emissions from the central black hole star and the blue ultraviolet emissions from the surrounding host galaxy, superimposed on top of each other. And the overmassive black hole problem? That turns out to be a measurement error. The standard method for calculating black hole mass involves measuring how broad the emission lines are. Broader lines mean faster-moving gas, which implies a more massive object at the center. But in a black hole star, photons don't travel cleanly outward. They bounce through the dense gas envelope repeatedly, shifting wavelength with each collision. The result is emission lines that appear far broader than they actually are. When researchers correct for this, the estimated black hole mass drops by orders of magnitude, bringing the LRDs back into a normal range. Black hole stars were predicted nearly 2 decades ago. In 2006, astrophysicist Mitch Begelman at the University of Colorado published a theoretical paper describing objects he called quasi-stars. His model described a black hole forming inside a dense gas cloud, not from the usual route of a dead star collapsing, but forming directly. Rather than the surrounding gas dispersing, it stays bound, and the whole thing glows like a star from the energy of the feeding black hole inside. Begelman even predicted they would be a brief phase in a black hole's early life, lasting only a few million years before the envelope cools and gets blown away, leaving behind a naked, rapidly grown black hole. That timeline would explain exactly why the little red dots appear in the early universe and then disappear. They were never permanent. They were a phase. One of the deepest unsolved problems in astrophysics is the origin of supermassive black holes. We know they sit at the center of almost every large galaxy, including ours. We know some of them were already billions of times the mass of the Sun just a few 100 million years after the Big Bang. The problem is that conventional models of black hole growth cannot get you there that fast. There isn't enough time. Black hole stars offer a possible solution. If the overmassive appearance of LRD black holes is partly a measurement artifact, and if the dense hydrogen envelope creates conditions where a black hole can feed faster than normal physics would allow, then supermassive black holes might be smaller than we thought and able to grow faster than we thought. The LRDs could literally be baby pictures of the black holes that now anchor every galaxy in the modern universe. There are still enormous open questions. Not all LRDs are confirmed to be black hole stars. The Rubies survey showed they are probably a mixed bag of different objects. The life cycle of a black hole star is still largely unmapped. We don't fully know how they form, how long they last, or what triggers the phase to end. Dozens of research teams around the world are working on this right now, submitting proposals for JWST observation time, publishing papers at a pace even experts are struggling to keep up with. MIT's Rohan Naidu, one of the scientists at the center of this work, put it simply: these are in every single image the telescope takes. We have to figure out what they are if we want to tell the complete story of the early universe. What makes the little red dots genuinely special, beyond the mystery itself, is what they represent. James Webb was built to see the universe's first light. And what it found wasn't just the beginning of stars and galaxies forming in the expected way. It found something nobody predicted. A class of object that sits outside every category we had. Something that may have quietly shaped the entire structure of the cosmos before disappearing without a trace. We are only just beginning to understand what they are. And if the black hole star theory holds, if Begelman's 20-year-old prediction turns out to be right, then the universe had a chapter we never knew existed. A brief, blazing phase where black holes wrapped themselves in stars and grew in ways that physics said shouldn't be possible. That chapter may have ended 1.5 billion years after the Big Bang. but thanks to James Webb, we're finally reading it. If this video gave you a new way of thinking about the early universe, subscribe so you don't miss what's coming next.